Assalamu alaikum and welcome to your students. Today's lecture is about physical optics, which is chapter 9 of the book Physics FSC Part 1. This chapter is about the wave nature of light, and in this lecture, we will cover the first two topics of this chapter. These topics are the wavefronts and Huygens principle. The nature of light always have been a very complex topic, and people have always questioned about the nature of light. What is the nature of light? People always try to understand if light is a particle nature or light is a wave nature or light is a dual nature, which means it behaves both as a particle as well as a wave. So always people always thought about these questions. Newton proposed in 1672 that light has a particle nature. So if light is a particle nature, this means that if we have some light source, for example, and we have some light source from where light is emerging, then light propagates in all the directions in the form of particles. However, later in 1678, Dutch physicist, his name was Christian Huygens, he proposed that light is not a particle nature, instead light is a wave nature. So if light is a wave nature, this means that light travels in the form of waves from the source of light. It travels in the form of waves in all the directions. When Huygens proposed this model of wave nature of light, by the time there was no experimental proof that light is a wave nature. So any kind of experimental proof was missing. There was no experimental proof that light is a wave nature. However, later in 19th century, in 1801, British scientist Thomas Young, he performed a very famous interference experiment, and based on this experiment, he proved the wave nature of light. So, based on his interference experiment, he proved the theory of Christian Huygens and confirmed that light has a wave nature. However, in today's time, people believe that light has both the particle as well as wave nature. So people mainly believe on duality of light nature. Because people believe for certain phenomena light behaves as a particle, and for other phenomena, light behaves as a wave. So light has a dual nature, both wave as well as particle nature. While in this chapter, the focus is mainly on wave nature of light. So this means in this chapter you will learn about, or you will study the properties of light which are associated with its wave nature. So in this chapter you will discuss the properties of light. Its wave nature. So to study or to discuss the properties of light as a wave nature associated with its wave nature, first we need to understand some basic definitions which will be used, and that's the first top. That's what is our first topic of this chapter, and that is wavefront. So in this topic you will learn about what is wavefront, what is array, what are what are the plane wavefronts. So we will understand the definitions of all these terminologies, and later on these terminologies will be used to discuss the properties of light which are associated with its wave nature. So we start first with what is wavefront. So a wavefront is a set of wavefront is a set of particles which oscillate or you can say vibrate in phase with each other and they are at same distance from the source or initial point. So a set of particles which vibrate in phase. So what is in phase? I will explain this term in a while. So all these particles which travel in phase, which isolate or vibrate in phase with each other, and they are at same distance from the source, this the surface which is formed from these particles is called a wavefront. Now, why we address here particles? Because when Huygens presented this theory that light propagates in the form of waves, then people asked him, how does these waves propagate? And then he says that they coined the term, or they, by the time there was a known term that a whole universe is composed of particles, and everywhere we have particle everywhere in the universe, and they named it as a ether medium, so they named it as a ether medium. Ether medium, which means that everywhere around us there are particles, and light moves when these particles vibrates, and due to these vibrations light moves in the universe in the form of waves. What does in phase mean? In phase mean when two waves they move. For example, we have two waves. We have wave 1, this is our wave 1, for example, we name it as a wave A, and then we take wave B, which is this. And in wave, the peak which we have, the peak is called always crest, and the valley for this part is called trough. So when crest of one wave, which is this, is exactly at the same point as crest of the other wave, or you can also say when crest of one wave falls on the crest of other wave and trough of one wave falls on the trough of other wave, then we call that these two waves are in phase. Also, you can say when they move in synchronization with each other. So if, for example, if this particle moves and this wave is moving in this direction, for example in this direction, and this wave is moving in this direction, and all the particles, this particle and this particle, they are moving in synchronization. When this moves up, when this particle starts moving up, this particle also starts moving up here and here, and when this moves up, this also moves up. So they move in synchronization. So this in synchronization movement is called being in phase. Contrary to that, the waves, if they are not moving in phase, they are called out of phase. For example, if we have two waves, again we take one wave, wave A, we draw it like this, and the other wave, wave B, is so in this case, now for the crest of this wave, which is this, is falling on the trough of this wave. So this is crest falling on the trough of the other wave, and in this case this is called as out of phase, because if we see this particle, they are not moving in synchronization with this wave. For example, when this is moving up, this one is moving downward, so they are not moving in synchronization. And similarly, when we are reaching here at the top point, then from here this point start moving down while this is moving up here. So they are not moving in synchronization with each other but opposite to each other. So in this case these waves are called out of phase. So in phase, or two waves are called in phase when they move in synchronization with each other, when each particle of the wave moves in synchronization with each other, and crest of the wave 1 falls on the crest of the wave 2, then it's called in phase. And if crest of wave 1 falls on the trough of other wave, this means they are not moving in synchronization, and that is called, these waves are called out of phase. So the definition of wavefront is a set of particles which isolate in phase with each other and they are at same distance from the source, this set of polymers forms a surface which is called wavefront. So to better explain you the concept of wavefront, I will give you the example of uh, waterways. For example, here we can check that. So here, for example, if we have pound of water and you just throw a pound in a stone in the pond of water right here, what you will see that from the position, the ripples of water, they start moving away from the original point, from where the stone of where the stone is thrown. So these ripples which are moving away, these ripples are actually called as a wavefronts. So why do they call wavefronts? If we see, so we have the we give the definition that the set of particles which vibrates in phase with each other. So if we look closely here at this point, for example, we have this let me take another color. So we have this point, we have this point, we have this point, we have this point, this point, this point, and this point. Now all these points which are on this, they are isolating in phase with each other. What does this mean? This means initially they are at lower level, and when they start moving up, then all the points moved up together, and when in the next, when they start moving away, they will move down. For example, here, let me take another color. When they will move here, then all the points will move down in this stuff at the same time, so in synchronization. So these moves up and down in synchronization with each other, and they are at same distance from the center. So distance of this particle is the same as a distance of this particle, because if we plot this one as a this is the side, what you see here is the side view, and if you see it from the top view, so we can say that we have, for example, this is our origin and this is our first ripple, and this is our, see, so it's not perfect circle, but you understand what I mean. So here we delete them. So, and also we will make it right in the center. So we have, this is our origin point, and from the center, all these points which I plotted here as I highlighted as a red, they are moving up and down from in synchronization with each other. So, and the distance of all of these points from the origin is same, which is ct, because the c is speed of light with which these mediums are, in this case water molecules are our medium, and they are moving away. So they are moving with the speed c, and after time t they will reach at this point. So if this particle will reach at this point, this particle will also reach at this point, and according to formula of distance, s is equal to vt. In our case here, what is the speed? Speed is the speed of light, and time is t. So this means this particle is at a distance which is ct, this particle is also at distance ct, this particle is also at the distance ct. So in that case we can say that because they are circular wave, so we have radius which is ct. So every point on this circle is at a same distance from the origin, Similarly, every point here on this surface is at the same distance from the origin, and similarly up to this point is at the same distance from the origin. So when they are at same distance and then they are isolating in phase with each other, then these set of particles, they form a surface which is called wavefront. So in this diagram of water pond where we have thrown a stone, all these ripples are known as a wavefronts. And the distance between any two wavefronts, so the distance between any these two wavefronts is known as a wavelength, which is represented by word lambda. So this distance between these two is wavelength. So it's the same like this one. So if we have a wave, so this distance between this point and this point, oops, it's not straight, let me plot it again please. If we have this wave, then the distance between this point and this point, this is wavelength lambda. So that is exactly here, this distance is the wavelength between these 2 points. So this is called wavefront. These ripples, which are particles which are moving in phase with each other away from the origin at the same distance, these are called wavefronts. And if we plot an arrow here, so which is indicating the direction in which these wavefronts are propagating, then this line is called ray of light. Ray of light. So you can plot this one also here, for example, and ray of light represent the direction of propagation of light, and it is perpendicular to the or normal to the wavefront. So this is also ray of light and it's perpendicular to the ray of light. So what is normal or perpendicular? For example, if we have some surface and this is any surface, and if we want to plot normal to this surface, this will be a perpendicular line on this surface. This is called normal line. So in this case, if you see, we have these wavefronts and normal to this, for example, if this is the surface of wavefront and normal to this wavefront is our this perpendicular line, and we call this ray of light. So this means we have clarified both in the topic of what is wavefront and what is ray of light. And now the question is, what is a plane wavefront? Because we have discussed wavefront, they are also can be considered as a spherical wavefronts, because these wavefronts are called spherical wavefronts. Now the next question is, what are the plane wavefronts? So if we have some light source which is here, and initially when we are very close to this this light source, then we have, for example, this is our spherical wavefronts. When we are close to the surface, then these are spherical wavefronts. Now if we look at this point, for example, if we want to look at this part of the wavefront, or here this part of the wavefront, so what you will see here, this part will look like more curve, because we are very close to the origin where it has originated. So this is more spherical wavefront. However, if we keep on moving away from this and keep on increasing distance and going very far from the origin, for example, now when we are very far from the origin, so what we have seen here, when we go away from the origin, the radius of this wavefront, the distance of this wavefront from the origin is increasing, which is radius. So for example, in this case it's a CT. In the next case, from here to here, it will be C into T plus delta t1 if this distance, for example, is delta, and this distance is covered in delta t1 time, and this distance is covered in delta t2 time, then this distance, total distance, will become c into t plus delta t1 plus delta t2, and so on so forth. When we will keep on increasing the wavefronts, then this radius will keep on increasing, and when we will reach here to a very far point, then the radius will be huge. And in that case, if we want to have the same region which we have here, which we plotted here, no, instead of curve it will be a straight line, because we are so away from the origin and the radius is so large that this part of the curve now looks like a plane. Instead of a curve, it's more a plane. So this wavefront, which is here is plane, is called plane wavefront. So this is the definition of a plane wavefront. So we have covered, so now you have understood what is wavefront, what is plane wavefront, and what is the rays of light. For example, this can be an example of sunlight. For example, if we see how our solar system works, then we will notice that if we have our sun, which is source of light, is here, and our earth is here, then all the wavefronts are reaching to our earth, and when they will reach to the earth, then the radius is so large that what we see here, we see only plane wavefronts instead of spherical wavefronts. So now we have learned about plane wavefronts as well as rays of waves and circular wavefronts. Now our next topic is Huygens principle. So when Huygens proposed that light is a wave nature and it travels in the form of waves, so then people start asking, how does it travels, whether it travels as a form of single wave, or how does it travels in the in vacuum or in normal environment around us. Does it travel as a single wave, or how does it travel in the medium? So to answer this question, Huygens proposed a principle, and this principle has two postulates. The first postulate of Huygens principle says that each point on the wavefront behaves as a source of wavelets. Secondary wavelets are wavelets. So what does this mean? This means that if we have a source of light here, and then we have light is propagating, and we have first wavefront here, This is our first wavefront, which is at some distance. Let's say it's at distance c t. Like I mentioned previously, c is speed of light and t is the time which light needs to travel from this point to this point. So this is the distance which we can say radius of first wavefront. Now, from first wavefront, how does the light travel to the next wavefront? So just like you see in the previous slides, if we see this diagram from the phone, so we have first wavefront, and then this energy is also transferred to the next wavefront, and then next wavefront, and so on. So people ask, how does this, in here we have molecules, and so water molecules which are traveling, how does when people ask Huygens, how does the light energy travel in this form from one wavefront, how do we generate it next wavefront, and how we generate third wavefront? So then the principle Huygens proposed, and according to this first postulate, Huygens proposed that each point on this, now if we take another point, for example, this point, each point of this wavefront will behave as a new source. For example, this point, each point on this wavefront will behave as a new source for the secondary wavelets. So for example, we had this source S, and this has generated this wavefront, and now all these points on this wavefront will also behave as a source, and then this source will generate new wavelet, and this one will also generate a wavelet, and this one will generate a wavelet, and this one will generate a wavelet, because every one of them is behaving as an individual source of light. So they will also generate new wavefronts or wavelets, and these wavelets then further move away from the surface. And now if we draw a tangent line on this surface, similarly if we plot tangent line on this surface, tangent on this, tangent on this, tangent on this, as well as this, and add them up, then we will form a new wavefront. So that's what is the second postulate of this Huygens principle, which says that at the new position of a wavefront can be found, the new position be found after a certain interval of time t, and time delta t, by constructing a surface with the tangents, or by touching the tangents of each wavelet. So this is second postulate of this principle. So the question, light waves travel, and in that case Huygens proposed that light travels in the form of wavefronts, and then in the first, when we have first wavefront, then each point on this wavefront further behaves as a source, new source. As a result of this new source, we have new wavelets, because all these sources are emitting new wavelets. So to explain you more clear, I go down to the page and make it relatively bigger for you. So if so this is our delta t time. So in time t, when we have first source, then we have traveled to the first wavefront, and each point of this wavefront behaves as a new source, and we have got new wavelets, and then we plotted the tangent. So what is tangent? So when we have any curved surface and we draw a line which is just touching the surface of this line is called tangent. So if you will plot on each of these wavelets a tangent, and then you will touch these tangents together, then you will get the new position of the wavefront, and this new position of the wavefront will be at a distance of c into t plus delta t. So t was the time which it took first wavefront to reach from the source, the time the first wavefront took to reach from source till this point, and then from this point the next wavefronts were reached to this point in time delta t. So total distance covered from here to here is c into t plus delta t. So in that way we can find the first, we can explain how the light travels. So light travels because we have in the form of wavefronts, and after one wavefront, when we have first wavefront, it behaves as a source, and then we have second wavefront, then each point on second wavefront also behaves as a new source. And similarly, if we will have third wavefront here, now we have second wavefront, so each point on second wavefront will also behave as a new source. We can draw with some different color or with red color. So each point here will also behave as a new source, and new wavelets will be generated. And similarly, from the third and fourth, these new wavefronts keep on generating, and light will keep on traveling. That is the first postulate. And second one is, if we want to know the shape and of shape and the distance of or position, shape and position of the second or third or fourth wavefront, we can easily found by checking after how much time this wavefront will reach here, and then by using this formula we can see that what will be the position of the wavefront, and by just adding up the or touching the tangents on this surface to each other, we will be able to also find what is the shape of the wavefront, as we have found here that if this is our first wavefront, the second wavefront is also our spherical wavefront, and third wavefront will also be spherical wavefront. However, if we will keep on moving in this direction, and when we will reach to a very far distance, then maybe our wavefront will not be anymore circular, but it will be a plane wavefront, just like this one. So depending on how far we are from the origin, so this is our origin radius, sorry, radius or distance, and this is our source. So depending on how far we are from the source, we can find what will be the shape as well as what will be the position of our new wavefront. So that is how it looks for circular wavefront. And similarly, if we have if you want to go to for plane wavefront, so we will have similarly, just like circular wavefront, we have, if we have plane wavefront, this is our plane wavefront, and then each point of this plane wavefront will also behave as a new source. So if we have this point, we have this point, we have this point, and this point, and this point, and each point of them will behave as a new wavefront, a plane wavefront. As a result, we will get our new wavefront also at certain distance, which is delta t time away. So if this is, again, if this is our origin, and from here to here we have traveled distance which is ct, and then this plane, it will take time delta t to reach from here to here. So total distance, the position of new wavefront will be c into t plus delta T, and the shape of the new wavefront will also be a plane wavefront. So depending on this situation, we can draw this better to make you understand better. Yeah. So depending on the so with this Huygens principle, we can find where is our, what is the position of our new wavefront, as well as what is the shape of our wavefront. So that's all from these two topics. I hope you people have understood what is the wavefront, what is the ray. So what we have covered here, we have explained what is the wavefront, what are the rays, what are the plane wavefront, as well as how we can find what is the Huygens principle, and what this Huygens principle tells us. First, for example, it tells us with the Huygens principle we can find the shape and position of any wavefront, and Huygens tells us that each wavefront, each point on the wavefront behaves as a new light source, and this new light source, if we combine, we touch the tangent of these two light sources, then we can find a new wavefront. And the position of each wavefront can be found by just adding and touching these wavefronts. So these are the first two topics of this chapter, and I hope you have learned understood these concepts. So with that, I would like to thank you for your attention, and after this I will also add the pictures of these two topics from the book, so that you can tell which book you are following and if they are same books. So thank you very much for your attention.